미적 측면에서 보자면 토성보다 아름다운 행성은 없습니다.
Saturn is the most photogenic planet in all the solar system. Some of the pictures are to die for.
하지만 사진은 토성의 일부만 보여줍니다.
Beauty's only skin deep. It really is roiling and seething inside.
토성을 위에서 관찰하면 육각형 모양의 폭풍이 도는 모습이 보입니다.
I could just imagine what it might be like to hold a ring particle in my hand.
엔셀라두스의 셈에 대한 미스터리는 더 많습니다. 염분이 있는 간헐천에 생명의 비밀이 감춰져 있을지도 모르기 때문이죠.
This is the little moon that has it all. And the samples are coming out in space. There's a big sign there, free samples, take one.
오렌지색의 큰 위성인 타이탄에 들러 안개 장막 아래로 내려가 봅니다.
I think it'd be, one of the seven wonders of the solar system.
타이탄의 하늘로 마술 같은 여행을 떠나볼까요?
The balloon just allows extraordinary possibilities for exploring Titan.
프로판 호수와 가연성이 강한 모래 언덕, 그리고 메탄 시냇물 위로 날아볼까요?
I mean, you could actually stand next to a babbling brook of liquid methane. I sometimes wonder, well, what would that sound like?
하지만 지구와는 전혀 다릅니다.
If you put your hand on a lava flow on Titan, you wouldn't burn your hand, you would freeze it.
과연 이게 전부일까요? 16억 킬로미터 거리의 행성으로 이륙해봅시다. 이젠 점점 더 가능해지고 있습니다. 이젠 인간이 가보지 못한 미지의 세계로 떠나기만 하면 됩니다. 로봇들의 발자취를 따라서 태양계 행성으로 여행을 떠나는 것이죠. 토성행 우주선에 탑승한다면 어떤 것들을 미리 알아둬야 할까요? 고리를 관찰하기 좋은 곳은 어딜까요? 위성은 꼭 봐야겠죠? 이 프로그램을 토성계의 신비함에 대한 안내서로 생각하셔도 좋습니다. 목성까지의 거리보다 2배나 더 먼 행성, 소행성대보다 4배나 더 먼 거리, 지구에서 16억 킬로미터 떨어져 있지만 토성은 늘 우리의 주목을 끌었습니다.
Saturn is the most phenomenologically rich planetary system that we have in our solar system. Because of its rings and planet and magnetosphere and an enormous collection of very diverse moons, it has it all. I mean, even just taking the rings as an example, in Saturn's rings we find examples of the other rings. Around Jupiter, around Uranus and Neptune, we find them in Saturn's rings. If you wanted to ask fundamental questions about the solar system in general, Saturn would be the place you would go.
On a 30-mile trek to Saturn.
1997년 본격적인 토성 탐사를 위해 카시니 호이겐스호가 발사됐을 때 우주선 안엔 우주에서의 오랜 모험을 위한 필수품이 가득했습니다. 발전기, 여분의 연료, 고성능 안테나, 위성 탐사기까지.
I figured once the data hit the ground, no one's going to want to be planning anymore. They want to look at the images, which is frankly how I feel. I don't want to.
이미지 처리팀 책임자 캐롤린 포르코는 고성능 카메라도 설치했습니다.
He's actually made quite a task for himself.
이번 탐사의 목적지는 명색이 태양계에서 가장 화려한 행성이었기 때문이죠. 토성은 태양계에서 2번째로 큰 행성이지만 이웃의 거대한 가스 행성 목성처럼 가스 덕분에 아름답게 보이는 것뿐입니다.
Well, Saturn is, first of all, a big giant gas ball. Actually, it's a big giant ball of fluid, and the outer parts of it are gases, atmospheres. But as you go deeper, it gets hotter and hotter, and also gets more pressurized. And so as you get down deep enough, you start getting sort of fluid effects. Very strange, bizarre physics going on that we don't fully understand.
토성은 몸집이 큽니다. 그에 비해 질량은 상대적으로 작아서 765개의 지구를 삼킬 만한 몸집이지만 밀도가 아주 작아 물에 뜰 수 있을 정도죠. 목성처럼 서 있을 곳이 없는 행성입니다. 단단한 표면이 없기 때문에 하루의 길이를 측정하기도 힘듭니다. 하지만 약 11시간마다 구름의 꼭대기를 자전합니다. 구름 꼭대기를 자전하게 하는 건 구름 아래에 있는 게 아니라 구름 위에 있는 어떤 것이겠죠.
If you were booking a tour for Saturn, the big ticket item I think would be see the rings of Saturn from X, wherever X happened to be.
토성의 위성에서 고리를 보면 정말 장관일 겁니다. 가까이서 본다면 이 반짝이는 원반은 수조 개의 얼음 조각이 모인 띠라는 걸 알 수 있죠.
It's just hard to imagine anything more beautiful than the ring system. They're the first thing that any kid with a telescope wants to look at.
집 앞마당에서 망원경으로 이 고리를 찾는다면 운이 좋은 겁니다. 토성이 태양 쪽으로 기울면 고리는 순식간에 사라지기 때문이죠.
The overwhelming thing that you as a space tourist would be struck by is how incredibly thin they are.
They're no thicker than about 1 or 2 stories in a modern-day building.
Much thinner compared to its width than a sheet of paper, for instance.
아, 직접 보고 싶으시다고요? 자, 굉장한 여정이니까 안전길 매시는 게 좋을 겁니다.
Roger roll, guys.
7년 동안 16억 킬로미터를 여행한 후 카시니 호이겐소는 2004년 6월 30일 최대 난관을 맞았습니다. 궤도에 진입하기 위해 먼저 고리의 장애물을 통과해야만 했던 겁니다.
Hopes and dreams of thousands of scientists and engineers are resting on the next few moments.
We've been to Saturn twice before with the Voyager 1 and Voyager 2 spacecraft, but rather than these quick Kodak moments, we wanted to take a nice, long, leisurely look at the Saturnian system. The only way to do that was to slow down and let Saturn's gravity capture us into orbit.
Current speed of the Cassini spacecraft, 50,000 miles an hour, and increasing as Saturn's gravity draws us in.
카시니가 진입합니다. 궤도에 떠있는 잔해가 없길 바라며 F와 G 고리 사이의 틈을 향해 나갑니다.
There was always a risk if we hit something too big in a very sensitive area like perhaps one of the computers or even the fuel tank that perhaps we might have ended the mission very early.
We turned the main high-gain antenna in the direction that the craft would see the ring particles coming toward it so that it would act as a shield.
자, 여러분은 지금 고리의 평면을 가로지르는 우주선에 작은 입자들이 부딪히는 소리를 듣고 계십니다.
Let's go ahead and switch Canberra over to B0.
지금까진 좋습니다. 하지만 카시니호가 무전이 차단되는 토성 뒤로 사라진다면 모든 것은 우주선이 얼마나 완벽하게 엔진을 점화해 속도를 줄일 수 있느냐에 달려 있습니다. 통제센터의 사람들에겐 초조한 순간이죠.
Go ahead and switch on.
The Doppler has flattened out. 토성의 어둠 속에서 나타난 카시니호는 다시 고리의 평면 위를 가로지릅니다.
To any potential inhabitants of the Saturnian system, your eyes are not deceiving you tonight. There is a 30-second moon gracing your night skies, and that is the Cassini-Huygens spacecraft.
토성의 62개 위성처럼 카시니오는 토성의 주변을 돌며 노련한 천문가도 감탄하게 만드는 지구에선 볼 수 없는 귀한 사진을 전송합니다.
Saturn is the most photogenic planet in all the solar system, so you couldn't get luckier than me, right? The ones that give me shivers are Saturn with the rings, where Saturn is a crescent. We're looking down on the rings from above, and there's a moon in the background. They are just artistic compositions. Here I am leading a team of scientists. Our duty, our job is to take images, and we have this fantastic target. Kind of have this feeling like I'm standing on the bridge looking out the window. I have a very strong feeling of being at the forefront, being out there exploring myself. That's the thrill of it for me.
카시니호가 촬영한 광경은 그 어떤 이미지보다 아름답습니다.
Lo and behold, as we got close enough, it looked like the rings dissolved into all of these, individual ringlets looking a lot like grooves on a phonograph record for people who remember phonograph records. And it was just very exciting then to try and figure out what could be causing that structure. What looked like rather featureless rings in a telescope now had, thousands of features in them.
I was surprised at how surprised I was at the clarity of the images, because I thought to myself, well, for Pete's sake, I've been thinking about this for years. For 14 years I've been thinking about this. I've been planning these images for a decade or whatever it was. You'd think I would have, anticipated, well, we're going to have this kind of resolution, it's going to look like this, and I just hadn't.
처음으로 토성의 고리에 대한 생생한 이미지가 공개되면서 더욱 본격적인 탐사에 대한 기대감이 어느 때보다 커졌습니다. 모두가 토성의 고리에 익숙합니다. 하지만 당신이 토성에서 엽서를 보낸다면 무엇을 강조하겠습니까? 모든 여행엔 꼭 가봐야 하는 곳이 있죠. 토성에선 고리를 놓치면 안 됩니다. 카시니오의 이미지 처리팀 책임자인 캐롤린 포로코가 탐사를 이끌어왔습니다.
The rings consist of just countless particles, and they range from big boulders the size of small apartment buildings, all the way down to the finest dust particle and everything in between. And they're all orbiting like crazy around Saturn at 20 to 40,000 miles per hour, but it's like traffic on a highway. Everybody can be going 90 miles an hour, but relative to each other, they're going very slowly. If you could put a spacecraft there and you could manage to move at the same speed, then the speed wouldn't be that dangerous at all.
You can think of rush hour on a Friday night, on the freeway, that the B ring has a lot of traffic and a lot of particles, whereas you go to the A ring, it's a little bit better. The C ring is more like being out in the country. You aren't going to see ring particles too often.
부서진 위성에 차내었던 고리의 입자들은 중력에 의해 납작해졌고 아주 얇은 원반 모양을 형성했죠. 그 직경이 30만 킬로미터에 달합니다. 지구에서 달까지의 거리와 비슷하죠.
I have, in fact, imagined myself orbiting Saturn, hovering over the rings. It's hard not to.
Oh, absolutely. You go there and take your own pictures, create your own postcards, hi Mom, here I am at Saturn's rings, it's great. I could just imagine what it might be like to hold a ring particle in my hand and see what does it look like. Is it like a fluffy snowball if I start to pull it apart? What's it like on the inside? So you can think of each of the rings, A, B, C, D, like different beaches. And so you'd want to collect samples from each of those rings.
토성 해변 위의 얼음알갱이들은 지나가는 물체들에 의해 씻겨나갑니다.
When a moon comes by, it creates a wake, just like a motorboat creates a wake that goes behind it. And I kind of imagine the ring particles doing an intricate cosmic dance around the planet, and can almost picture like little ballet dancers, each with their own orbits and paths, and sometimes colliding and encountering, and sometimes not.
이 우주벌레의 비밀이 더 자세히 밝혀진 건 빛의 마술 덕분이었습니다. 매 15년마다 토성이 태양 주변을 천천히 돌면서 남북의 계절이 바뀝니다. 2009년 카시니오는 토성의 춘분을 관찰하기에 최적의 위치에 있었습니다.
The sun at exact equinox will be shining exactly edge on to the rings. But a little bit before and a little bit after, the sun will be low to the rings, just like the sun is now low over London. Any vertical protuberances, either up or down below the rings, will cast very long shadows. And we have in fact found that the rings aren't completely flat. There are places where the ring particles in fact form these structures that soar a mile or 2 or 3 above the plane of the rings. The first time in 400 years we now know that the rings are three-dimensional.
혹시 들어보셨나요? 토성계에서 가장 관심의 대상이 되는 것은 작은 위성인 엔셀라두스입니다. 생명체를 찾기 위한 우주 탐사에서 가장 주목받는 곳이죠. 하얗게 빛나는 엔셀라두스. 토성의 이 고리 내에 숨어있는 밝은 구체. 카시니오가 탐사를 시작하기 전까진 이 별은 그저 평범한 위성이었습니다. 하지만 뭔가가 수상했죠.
It was first found by the magnetometer team. They saw this hint of something in the magnetic field of Saturn wasn't just right. It was being kind of deflected to the side.
It was like unraveling a puzzle, and so the magnetometer team said, let's go closer. And as we got closer, we watched as a star went through and noticed the change in brightness. Something is going on.
We could see even from a distance, there seemed to be this material coming off the South Pole. And it was so dramatic and so unusual that we thought, well, it might be a camera artifact.
엔셀라두스는 직경 500km의 작은 별입니다. 특이한 지질학적 특성을 갖기엔 너무 작죠.
If you look at Enceladus, it kind of looks like it's covered in snow. It's very bright. It's as bright as freshly fallen snow.
Everywhere you look, there's fractures. There are mountain ranges and there are deep chasms. And when we finally looked at the South Pole, that's when it just became apparent. That's where all the activity is going on.
연구진은 아주 멋진 장면을 발견했습니다. 줄지어 늘어선 간헐천들이 눈처럼 흰 표면으로부터 물과 얼음 결정을 우주로 쏘아 올렸던 겁니다.
And so it was like a giant detective story, piece by piece putting the evidence together until finally you get back that really great picture, the smoking gun, showing the geysers actually coming out from the south pole of Enceladus.
Water and water ice are spewing out of giant cracks from a region about the size of Southern California that's apparently just basically a big geothermal field. You can think of it that way.
캘리포니아처럼 보이진 않습니다. 많은 이들의 예상처럼 태양에서 멀리 떨어진 얼음의 위성일 뿐이죠. 하지만 그 점이 이 별의 신비입니다.
I mean, the bloody thing is hot. The South Pole is hot. Okay, it's like, it's as crazy as saying the North Pole of the Earth is hotter than the equator.
가장 설득력 있는 설명은 남극의 얼음 지각 밑에 숨은 대양 혹은 바다가 수원이며 조수의 가열 작용에 의해 온도가 상승했다는 것입니다.
It's been a mystery because Enceladus is so small. It's not supposed to have that much heat. We think that heat source underground melts water, and that melted water, which might be mixed with some ammonia and other things to lower its melting point, then works its way out of the ground and spews up into space.
Here is the surprise entry in the search for life. This little moon that you'd expect to be pretty dead and dull, and coming out of the south pole of it is a jet of water ice. All the things you need for life are there. There's an energy source, there's a water source, there's an organic material source, there's a nitrogen source. Check, 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 check. All the requirements for life. This is the little moon that has it all. And the samples are coming out in space. There's a big sign there, free samples, take one. We just fly through and grab it on our way.
I think it is the go-to place in our solar system right now for investigating issues of astrobiological importance. It wins out the game over Mars, over Europa, over Titan even, simply because of accessibility. It's accessible. If these jets are deriving from liquid water, then they're there for the sampling.
카시니 팀은 우주선을 남극의 분출 기둥에서 25km 거리까지 근접 비행시켰습니다. 리모컨으로 조종하는 이 놀라운 정밀 비행은 원래 지구에서 16억 킬로미터나 떨어진 이 행성을 위한 건 아니었습니다.
From Cassini, we learned that there's methane in the plume, nitrogen in the plume, ammonia in the plume, organic molecules in the plume. It's a real soup. We're seeing a soup of organics being spewed out into space where it's freezing. You can almost go there and jar it, put it in a can, and sell it on Earth as organic nutrient soup.
지구에서도 간헐천과 온천은 생명의 기원에 대한 단서를 제공해주는 박테리아의 고향입니다. 물론 경이로움도 선사하죠. 하지만 지구의 온천은 엔셀라두스의 그것과는 비교도 안 됩니다.
So sitting there at the South Pole of Enceladus and taking a look at Saturn while you're sitting there watching this eruption going on would be beautiful.
It wouldn't be a dangerous thing. You would see these towering, dramatic fountains of just icy particles. We'd never see them stop because some of them actually extend tens of thousands of kilometers into the space above the South Pole and in fact into orbit around Saturn. This is how the E-ring of Saturn is formed.
카시니오는 적어도 토성의 고리 중 하나가 어떻게 형성됐는지 알려주었습니다. 그리고 이 사실이 지구 밖에 존재하는 생명체에 대한 의문을 풀 수 있게 도와줄 겁니다.
I can't think of anything that would be more thrilling than to make that kind of discovery, that life has occurred not once but twice in our solar system, and to know that it might be on Enceladus, which is a body that we have been exploring and that we have participated in this discovery is it doesn't get much better than that.
T-minus 2 minutes and counting.
엔셀라두스가 가장 주목받는 건 사실이지만 모든 걸 갖춘 위성이란 타이틀에 도전하는 경쟁자를 무시해서는 안 됩니다. 바로 타이탄이죠.
T-minus 40 seconds. Everything looks good for launch.
수성이나 명왕성보다 큰 토성의 위성 타이탄은 지구와 금성을 제외하곤 단단한 땅과 두터운 대기를 가진 유일한 별입니다.
Titan, if it weren't in orbit around another planet, we'd have really no hesitation in calling it a planet in its own right.
We knew going that Titan was going to be exciting. Titan was a mystery hidden inside this hazy, smoggy atmosphere.
카시니오는 두터운 오렌지색 안개에 쌓인 타이탄을 보여줬습니다. 연구실에서의 실험은 이것이 질소와 메탄으로 구성된 두터운 대기와 햇빛이 45억 년 동안 반응을 일으킨 결과임을 암시하고 있습니다. 카시니의 카메라가 보여줄 수 있는 건 한정적입니다. 밝고 어두운 점들이 마치 대륙과 바다처럼 보입니다.
The picture we had of Titan before we got there was that it was going to be dark and eerie and cold. As dark as twilight is on the Earth, even at high noon, and you could be standing on a body the size of the Mediterranean, brimming with paint thinner.
유럽에서 7년이 넘도록 오랜 시간 만들었던 호이겐스 탐사기는 미국의 우주선 카시니오에 실려 있었습니다. 그러다 2004년 크리스마스에 마침내 발사됐습니다. 그렇게 멀리 떨어져 있는 별에 착륙을 시도해 본 적은 없었죠. 호이겐스 탐사기가 타이탄에 접근하면서 탐사는 이제 유럽의 지휘를 받게 됐습니다.
The probe hurtled into Titan's atmosphere at 6 kilometers a second. The atmosphere would have been glowing violet around the probe as it decelerated.
낙하산에 매달린 탐사기가 130km를 하강하면서 볼 수 있었던 건 안개밖에 없었습니다.
As we got closer to the surface, down at about 30 kilometers, the surface features started to peek through the haze. Progressively, this landscape emerged of these bright hills cut by small dark channels that showed that there had been rain there at some time in the past.
신호가 지구에 도착하는데 1시간이 넘게 걸렸지만 호이겐스는 먼 우주에서 우편 엽서를 보내왔습니다.
There were just 20 of us in the office area where the pictures were delivered. It was dark in Germany, it was the winter. It really felt like we were out there gazing at this alien world that was just at our doorstep.
탐사기는 이동을 계속하면서 이 놀라운 이미지들을 계속 전송했죠.
We all kind of saw, our backyard in Arizona or the French Riviera, wherever it was you were from, you sort of saw some aspect of Titan that looked familiar.
They were everything that our images from orbit were not. Because you could see a dendritic drainage pattern that looked like a river system, just like a river system would appear on the Earth. Boy, that was heady. That was like, it was like Jules Verne come true. It was just spectacular.
타이탄에 착륙한 호이겐스는 수백 장의 사진을 지구로 전송한 후 배터리가 방전돼 마침내 영원히 작동을 멈추고 말았습니다.
The probe landed with a thud on basically a streambed, an area littered with rounded cobbles that showed that these little rocks or ice particles had been tumbled around in a stream at some point in the past.
The whole thing just was very chilling, not in the sense of temperature, but just in the sense of what we were looking at. It was very, very alien.
It's not a place where you want to just jump out there in your shoes and socks and shorts and t-shirts. It's roughly 200 degrees Fahrenheit colder than dry ice.
표면 온도가 굉장히 낮기 때문에 아무것도 존재하지 않는 것처럼 보입니다.
Titan is the world with liquids. The difference is the liquid is not water. The liquid is methane. Think of gasoline. It's a liquid like white gas.
So you've got rivers of methane flowing on the surface. Anybody who's looked out of an airplane window flying over deserts and things like this say, yeah, I sort of understand what's going on the surface there.
Because it's so cold, water behaves like rock does and methane behaves like water does, but everything's just sort of shifted along the scale of volatility.
전혀 다른 세계가 지구와 아주 흡사한 풍경을 갖고 있다는 사실이 정말 놀랍죠. 나사의 제트 추진 연구소에서는 메탄 빗방울이 시간이 지남에 따라 어떻게 화강암처럼 단단한 지형을 형성했는지를 연구하고 있습니다. 한 방울씩 떨어뜨리면서 말이죠.
So it's like rain on Titan, and we can see that when a drop is falling onto the ice, it just gets into the ice. It just disappears in the ice. Just incredible how much methane can be stored in the ice.
물이 땅 속으로 흡수되듯이 메탄이 얼음 속으로 스며들고 넘치는 메탄은 길을 내며 흐르게 됩니다. 지구에서처럼 말이죠.
Titan would be a wonderful place to visit. Stand next to a babbling brook of liquid methane running by your feet, and I sometimes wonder, well, what would that sound like?
In fact, as we took radar pictures of other parts of Titan, we found even wilder things in the northern polar areas. There are entire lakes or even seas that looks to all the world like you could go take a boat and go to jet skiing or something right, up and down these channels there.
Titan is the only other place in the solar system that we know liquids exist on the surface. So here you have vast reservoirs of liquid natural gas, and oh, by the way, we've thrown in some ethane, which is a slightly more complex hydrocarbon, and oh, by the way, there's some propane in there. Everybody knows what propane is. You use it in your backyard barbecue.
카시니의 레이더는 내륙의 바다만한 호수를 탐지했는데 슈피리어 호보다도 큽니다.
Imagine standing on the shoreline of what to you looks like an ocean of liquid hydrocarbons. That's gotta be pretty special.
호수가 내키지 않으신다면 화산에 가보십시오.
We think the material that comes out of titanium volcanoes is a mixture of ammonia and water, which allows water to melt at a much lower temperature.
이것이 타이탄의 용암입니다. 냄새가 고약한 물과 암모니아의 혼합물로 녹는 점이 영하 100도 정도 됩니다.
You can build anything from small cones to large mountains on Titan out of this stuff. If you were a visitor and you walked up and put your hand on a lava flow, you wouldn't burn your hand, you would freeze it.
얼음 화산이나 호수가 많은 극지방과는 지극히 대조적으로 적도 지역엔 모래 언덕으로 뒤덮인 광활한 사막이 위치하고 있습니다.
I think it'd be one of the seven wonders of the solar system. What you'd see is almost unending sea of massive dunes, exactly the same size and scale of dunes that we see on Earth. Some areas where you see nothing but dunes for hundreds and hundreds of kilometers.
카시니가 보낸 영상을 분석하기 위해 랄프 로렌즈는 호주의 오지를 찾아갔습니다. 타이탄만큼은 아니지만 멀리 떨어진 곳이죠.
One of the interesting things going on here in Australia is that there are linear dunes, which are the same kind of dunes we see on Titan.
You can go right up to a sand dune on Earth and dig in it, make a cross-section and see how the beds of sand particles line up to see how the thing formed under different wind regimes.
두 곳의 모래 언덕을 비교해보면 타이탄의 부는 바람의 특성을 알 수 있죠. 이것은 타이탄의 극저온 기후에 대해 알 수 있는 단서가 됩니다. 막 결빙된 커피밭에 내리는 비처럼 타이탄의 부는 바람은 지표의 20%를 뒤덮는 모래 언덕을 만들고 그 모래 언덕은 취상품 커피처럼 짙은 색을 띱니다.
The dunes represent a massive inventory of organic material, hundreds of times larger than all the coal, for example, on the Earth.
이 위기의 석탄을 집에 가져올 수는 없겠지만 타이탄의 호수에 넘치는 액화 탄화수소는 지구로의 귀환을 위해 유용하게 사용될 수 있을 겁니다.
There's more, let's call it fossil fuel type energy than we actually have known reserves on the Earth by a factor perhaps of 10 or even 100.
실로 엄청난 양인 것만은 분명합니다. 하지만 이 유기분자의 보고에서 훨씬 더 귀중한 것이 발견될 수도 있죠. 생명체와 우주, 그 모든 것에 대한 해답 말입니다.
How do you go from such simple material like carbon and hydrogen and oxygen and nitrogen to something which asks questions about where it came from? That's a huge leap. And on Titan, there's a real good possibility that some of those really difficult to understand intermediate stages actually occurred. It hasn't gone to completion, at least we don't think it has, although there are some people who think that if we go to one of Titan's lakes, we will discover titanian bacteria that have figured out how to metabolize liquid methane.
Well, that's not a liquid that we on life forms on Earth like, but maybe a life form on Titan that grew up with liquid methane would be perfectly comfortable there and would look at shock at the thought that organisms would live in water. Oh my God, those things on Earth living in water. Pity those poor Earthlings. We live in liquid methane, much more pleasant.
타이탄은 태양계의 생명체를 찾기 위한 시험장입니다. 만일 이 외계의 별에 생명체가 살고 있다면 다른 곳에서도 살고 있을 수 있으니까요. 호이긴스 임무는 타이탄에서 끝나는 것이 아닙니다. 카시니 역시 토성이 종착지가 아닐 겁니다. 이제 막 시작된 여행에서 용감하게 내딛는 첫발일 뿐입니다. 임무가 끝나기도 전에 카시니오는 타이탄에 다시 한번 가고 싶어졌습니다. 행성 탐험가인 조나단 로나인 박사와 항공 전문가 줄리언 노트는 완벽한 방법을 알고 있습니다. 바로 원격 조종 열기 구조.
So what we're flying over now is very much like the Huygens landing site. And I'd love to see those ravines on Titan, those steep valleys where the methane is flowing and carving out the hills, very much like what we're seeing now.
타이탄으로 돌아가서 대기 속으로 원격 조종 기구를 낙하시키는 것이 목표입니다. 방사성 동위 원소 발전기가 전력을 공급하고 폐기물을 태워 추운 대기 속에서 기구를 띄워줄 열을 공급해 줄 겁니다.
Titan has a dense atmosphere, it's cold, the gravity is low, the winds are gentle, so ballooning is very easy.
The conditions on Titan are 1,000 times better than anywhere else in the solar system to fly balloons. It is the ultimate destination for balloons. I think this flight just makes the point so beautifully why a balloon is a wonderful way to explore Titan. If you're over an interesting area, very easy to come down, maybe even land on the surface, lower instruments down.
One could cover with a robotic hot air balloon the entire circumference of Titan in a space of perhaps 6 months.
로봇만이 타이탄에 갈 수 있는 건 아닙니다. 두터운 보호 대기와 결빙 상태의 물 덕분에 타이탄은 지구인에게 화성보다 훨씬 안전한 방문지가 될 수도 있습니다.
When humans do finally move out into the solar system, and I think they will, Titan will be seen as a somewhat distant but very attractive place to go play. You don't need a pressure suit on Titan. You don't have that feeling, as the astronauts describe it, of trying to work with a beach ball between your arms.
개선된 호흡 장비로 숨을 쉬고 스키복처럼 생긴 안전복을 입고 임무를 수행할 탐사대는 지금보다 훨씬 편안하게 활동할 수 있을 겁니다.
You just need that thermal protection and oxygen, and then you can go play on the surface and take a balloon ride. It'll be a place where people will want to go to see a truly exotic and alien world.
우주복이 약간 손상돼도 치명적이진 않을 겁니다.
I did a calculation once of whether the small amounts of carbon monoxide in Titan's atmosphere would kill you before the hydrogen cyanide did. Actually, it turns out both are probably only enough to give you a headache, but the place would probably smell like an oil refinery.
연료 얘기를 해볼까요? 비행을 위한 연료 공급은 가장 가까운 호수에 내려 메탄 로켓을 채우기만 하면 끝납니다. 기술 개발도 거의 끝났죠. 타이탄까지 갈 수 있다면 엔셀라두스라고 못 갈 이유는 없겠죠?
The real question is not, does Enceladus have organics? Well, we know the answer to that. Or does Enceladus have water? We know the answer to that. The question is are those organics biological in origin? So on Enceladus, we are many steps ahead of where we are in terms of Mars or Europa. We already know that there's organics. We already know where they are. We already know how to get them. It's time to bring them back to Earth and look at them and ask the next level of questions. Are they biological?
It may not happen for a very long time, but I really think that's a must-do for us in taking the next step. And to me, the question of whether or not life has gotten started elsewhere in the solar system is the reason why we do this. You know, because we want, finally, ultimately, we want to come to understand why the Earth has been the successful abode of life that it has become.
역사적인 탐사 활동이 새로운 국면에 접어들면서 카시니 탐사팀은 최근 런던에서 만나 그동안의 상황을 평가하고 향후 계획을 세웠습니다. 자신들의 58번째 만남을 축하하기 위해 이들은 그리니치 왕립 천문대를 택했죠. 이곳의 바닥에 표시된 본초 좌우선은 경도의 기준으로 모든 위치를 측정하는 기준선입니다.
We have taken something that is so far beyond human reach, it's almost unimaginable, and we have brought it home.
바로 이것이 토성에 가까이 간 인간이 처음 볼 수 있었던 이미지이자 지구에 있는 인간이 보게 된 이미지입니다. 토성의 아름다운 고리색에 묻혀 희미하게 보이는 푸른색 점 하나. 이것이 카시니오가 지구의 인간에게 보이는 우주의 모습을 담은 또 한 장의 엽서입니다.
Humans have looked out from the shores of seas and oceans and imagined great adventures. Now think about standing on the shore of an alien sea, and we know those shores are there. We just have to go experience it, and that's what I'd like to do. I'd like to go land in a balloon, step out, pick up one of those rounded pebbles, and toss it at Huygens.
I've proposed that maybe we have to talk about a planetary park down the road, and where should we preserve for future generations? You know, do we want to go in and mine Titan for its methane? Maybe we'll go mess up other places, perhaps, but Saturn is just an exquisite place, and we should probably leave that alone.
탐사해야 할 흥미로운 위성이 아직 많지만 나사는 카시니오의 임무가 끝나게 되는 2017년이 되면 또 어떻게 할 것인지 계획을 수립하고 있습니다.
We want to make sure that the spacecraft doesn't hit one of these bodies, and so what we're going to do is put it into the atmosphere of Saturn.
Crash it into Saturn and burn it in a blaze of glory after a rich 20 years of exploration in space.
All the molecules that currently make up the Cassini spacecraft would still be at Saturn, and in fact will be there forever.
인류 역사상 가장 위대한 행성 탐사선은 결국 영광스러운 최후를 맞이하게 될 것입니다. 가스로 가득 차 물에 뜰지는 모르지만 토성은 과학을 위해서든 장엄한 경관을 보기 위해서든 꼭 가봐야 할 행성입니다. 우린 이제 막 토성에 숨겨진 것들을 깨달았고 그것은 우주선을 보내는 모험을 감행했기에 가능했습니다. 태양계의 다른 행성도 마찬가지입니다. 모험을 하지 않으면 무엇을 놓쳤는지 결코 알지 못할 것입니다.